The tangent to a circle at a point is perpendicular to the radius at that point. So this point is the point of contact of the tangent and the circle. So tangent only touches the circle at one point. In this example, we want to prove that the line 2x plus y minus 2 equals 0 is a tangent to the circle x plus 5 squared plus y minus 2 squared equals 20. Now, one way to do this is to draw a sketch. This is a sketch of the circle. The center of this circle is got by changing the sign of plus 5 to minus 5 and changing the sign of minus 2 to plus 2, as we saw in the previous video. The radius squared is 20, so the radius is the square root of 20. This line is 2x plus y minus 2 equals 0. So we're jumping ahead a bit here. We showed a line touching the circle at one point, which is what we're trying to prove actually. But you can see from this sketch an approach to proving that this line is indeed a tangent to the circle. We get the distance of the center of the circle to the line 2x plus y minus 2 equals 0. By distance we mean the shortest distance of a point to a line, or the perpendicular distance of a point to a line. And if the perpendicular distance is equal to the radius, then this line 2x plus y minus 2 equals 0 is indeed a tangent to this circle. So here's the formula that I covered in the playlist on coordinate geometry of the line. This gives us the distance of a point to a line. Our line has to be written in the form ax plus by plus c equals 0, and it is. So I'll just write down the form that the line must be in so that we can use the formula. So we can see that a is 2, b is plus 1, c is minus 2 for this line. We label the point x1, y1, so we can see that d is the magnitude of a, which is 2, times x1, which is minus 5, plus b, which is the coefficient of y, which is 1, times y1, which is 2, plus c. C is minus 2. We divide this by the square root of a squared plus b squared. That's the square root of 2 squared plus 1 squared. So we get minus 10 plus 2 is minus 8. Minus 2 is minus 10. And we get root 2 squared plus 1. That's root 5. So we make this positive. We get 10 over root 5. Now, is this equal to the radius? The radius of this circle is root 20. That's what we have to prove. If the perpendicular distance of the point to the line is equal to the radius, then the line must be a tangent to the circle, because only the tangent is perpendicular to the radius at the point of contact. Well, to see if this is equal to this, we can just cross multiply. That's the easiest, quickest way to do this. Well, root 5 by root 20 is root 100. So we get 10 equals root 100. Is this true? Of course. So d is equal to the radius, and we can conclude from that the line 2x plus y minus 2 equals 0 is a tangent to this circle. A chord of a circle is a line that just cuts 2 points of a circle. The diameter of a circle would be the longest chord. A radius that is perpendicular to a chord of a circle bisects the chord. So in this picture here, this line here is part of a radius. It is perpendicular to this chord here. So if it's perpendicular to this chord, then it bisects the chord. So these two lengths are the same. C is a circle with center minus 3, minus 1. 1, 3 is the midpoint of a chord of length 4, root 2. Find the equation of C. So here is the circle centered at minus 3, minus 1. Here is a chord of length 4, root 2. The midpoint of the chord has coordinates 1, 3. We want to get the equation of the circle. Now there are two things we need for the equation of a circle. We need the center of the circle, which we have, and the radius of the circle. So I've drawn in a radius here from the center to one of the points on the circle, this point here, the end of the chord. Now we're given that the length of the chord is 4 root 2. So we use the property that since this radius bisects the chord at the point 1, 3, since we're given that, then we can work out this length here. The total length of the chord is 4 root 2. So this length is half of 4 root 2, which is 2 root 2. So to get R, we use the fact that we're working with a right angle triangle here. So what we need to do is find the distance from minus 3, minus 1 to 1, 3. I'll call this distance D. So how do we find D? Well, we have the coordinates of the endpoint. It's just an application of a distance formula. The distance formula just comes from Pythagoras' theorem. To get the distance between 2 points, we just subtract the x values. We can call them this one x2, y2 if we like, and this point x1, y1. We'd have the square root of x2 minus x1 squared plus y2 minus y1 squared, where y2 is minus 1 and y1 is 3. So we just subtract the x values to get the horizontal distance between the points, square that, subtract the y values to get the vertical distance between the 2 points. It's y2 minus y1. And then we just have Pythagoras. So I've explained this before. We have 4 squared in here, 16. We have another 4 squared, another 16, so we get the square root of 32. So to find R, we just apply Pythagoras to this right angle triangle. So the square hypotenuse, well, the hypotenuse R is the square root of the sum of the squares of the 2 shorter sides. So D is root 32 and this side is 2 root 2. Root 32 squared is 32. 2 root 2 squared is the same as 4 times 2, which is 8. So R is the square root of 40. We know that this is the general equation of any circle, x minus h squared plus y minus k squared equals r squared, where k is the center and r is the radius. H is minus 3, so x minus h is x plus 3. K is minus 1, so y minus minus 1 is y plus 1. And the radius is root 40. Root 40 squared is just 40. So this is the equation of C. The angle in a semicircle is a right angle. Here we have a circle with a diameter. C is the center of the circle. If we pick any point on the circle, such as this point here, and join it to the endpoints of the diameter, the angle between these 2 lines is always 90 degrees. It doesn't matter which point we pick. We could pick this point here, and we will find that this angle is 90 degrees, or this point here. It doesn't matter. So the semicircle is half a circle. So the circle is cut in 2 by this diameter. In this example, we want to show that the equation of a circle whose diameter has endpoints x1, y1 and x2, y2 is x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals 0. What we do is get the slope of this line here and this line here, and then we use the fact that the 2 lines are perpendicular to each other, which means that the slopes are inverses of each other. So I'm going to call this line L. So let's get the slope of this line. Well, to get the slope of a line, we just subtract the y values. That gives us the rise for this line. So I've taken this as the starting point. So I have y minus y1. Then we divide by the run, which is x minus x1. Okay, so you can think of this point as x2, y2, and this one as x1, y1. So we have y2 minus y1 over x2 minus x1, basically. So that's the slope of line L. Now, because L is perpendicular to M, if we multiply the slope of L by the slope of M, we get minus 1. So let's write in the slope of M. Well, starting with this point, we have y minus y2. It's the difference in the y's over x minus x2. So we have the slope of L times the slope of M must equal minus 1. So for example, if one line has a slope of 3/4, then the other line must have a slope of minus 4/3. So one line might have a positive slope, then the other line must have a negative slope. And when you multiply the slopes, you get minus 1. That's the case for perpendicular lines. In this line here, I've just multiplied across by the denominator. So the denominator consists of x minus x1 and x minus x2. So multiply the whole thing by this denominator, and we'll get this line here. And then we just bring this over to the left-hand side, and that proves our result. Just to see this thing in action, let's suppose that this point here is minus 1, 3. Well, it isn't on this diagram, but I just want to use integers. And let's suppose that this point is 5 minus 1. Well, we can plug them into our formula, and we will have the equation of the circle whose diameter has endpoints minus 1, 3 and 5 minus 1. So what are we going to get? x1 is minus 1, so we're going to get x minus minus 1 or x plus 1 times x minus x2, that's x minus 5, plus y minus y1, that's y minus 3, times y minus y2, that's y minus minus 1 or y plus 1, equals 0. So we can multiply all of this out. Here we get x squared minus 5 plus 1 is minus 4x minus 5. Then we have y squared plus y minus 3y is minus 2y. Then we have minus 3. You can write the x squared and y squared terms together. That's the usual way for writing down the equation of a circle when it's fully expanded out. Then we have the x term, the y term, and finally the constant term at the end. Now, the other way to get the equation of a circle is to use the formula x minus h squared plus y minus k squared equals r squared. Well, this is the way that we've learned so far. So to use this formula, we need the center hk and the radius. Well, what's the center of this circle? Well, it's the midpoint of the endpoints of the diameter. So how do we get the midpoint? Well, we get the mean of the x values. So we have 5 plus minus 1 is 4 divided by 2 is 2. Get the mean of the y values. 3 minus 1 is 2. 2 divided by 2 is 1. So this is hk. Now what's the radius? Well, the radius is the distance of the center to either endpoint. So I've got the distance of the center to this point here. Just use the distance formula. Root x2 minus x1 squared plus y2 minus y1 squared. So you'll get root 3 squared plus 2 squared. You'll get root 13. So we have the center hk and we have the radius r. So we plug them into this. So we get x minus h, well h is 2, plus y minus k, where k is 1, squared equals r squared. Root 13 squared is just 13. Now if we expand this out, it should be the same as this. So now let's expand it out. Now this is something we haven't done before. Normally we have left the equation in this form, although I fully expanded out it over here. Let's do it here. Let's square this out. We get x squared minus 4x plus 4 plus y squared minus 2y plus 1 equals 13. So we write it in the so-called standard form, write x squared and y squared together, then the x term, then the y term. If we look at the numbers, 4 plus 1 is 5, bring the 13 over, 5 minus 13 is minus 8. So it does check out both ways. The nice thing about this formula here is the symmetry. See, this term has the same form as this term here. Just interchange x with y. We will probably never use this formula. It's very handy if you know the endpoints of a diameter, but usually we will be working with this formula here.